Hi guys, welcome to my YouTube channel, and in today's video we will be discussing about the internal working of node.js. So I'm not sure if you're following up my video series. So from the beginning I have been developing this content on how your web servers work, how your application server works. And as part of that roadmap, I'm creating this Node.js internal implementation of Node.js. So let's quickly begin with it. So as part of this video, we will do a deep dive into how majorly the part will revolve around the request handling of Node.js, because you see, in today's world, Node.js is serving a lot of powerful applications that you use as a user day in day out of your life, right? So do you agree with me or not? So what you can also tell me your opinion, right? You can comment it down. What do you think that Python versus Node.js, who is leading the world nowadays? Just comment it down. Also, if you want me to create a video, right, the Python versus Node.js comparison, you can just comment it down yes. Then I'll try to come up with a new video on Python versus Node.js. So let's not waste much of our time and then quickly begin with the Node.js internal implementation and working. So do you even out of this video you can only get if you understand the blocking IO, because if you see Node.js revolves around totally, it's kind of a non-blocking IO operations, right? It has non-blocking IO operations. So when I say blocking IO and when I say non-blocking IO, so first of all, let's understand what is blocking IO. When I say blocking IO, what I actually mean by it, right? So let's quickly recap on the blocking IO based web servers working. So because in my other video on where I discussed about the Apache Tomcat web server, there I have explained that it's a blocking IO. It totally works on the blocking IO operations. And also, if you go and check out my how Tomcat works video, it's also tagged as the Spring Boot working video, you will get an idea that how the blocking IO input output operation works. So let's go back. Let's go to the designing part and understand how your blocking IO operation works first of all, right? So let's say you have your client here, right, and then you have your app here, right? So the way your blocking IO works, so what do you mean by blocking IO? It means that let's say there is client sends a request to your application, right? So now, so the way it works, when client sends a request, it will create a TCP connection to your operating system, right? And then through your operating system, your operating system will be listening on a particular port number for that particular TCP connection to happen. Now, once that TCP connection has been made, a particular thread will be assigned to that particular request to process further, right? So it's kind of known as one thread per request model. All right. Now, what will happen is from here, your app has taken that request and then it is being served by one thread, right? So now that thread, maybe that thread as part of the request, that particular thread talks to your database, right? Or let's say you have some other service here. You may be calling an API. So it is again, these are all nothing but the network calls, right? So you see, so your thread here, yeah, right? Your thread here will be blocking. So let's say your thread has made a network call to your database, right? So till the time that particular response comes back from your database, your thread will be in the waiting state right here, right? In the waiting state. So that's kind of a blocking operation. You see, it's kind of a blocking operation. Why? Because your thread is being blocked till the time it gets the response from the call that it has made, right? So it could be anything. You may be calling, you may be doing a disk operation, you may be using some kind of operating system, anything, or maybe it may be doing a database network call. It may be calling a different microservice. It could be anything. The point is your thread will be in the block state till the time it gets the response back, right? So that's the basic blocking input output operation, right? So now, and we also understood the fact that it in the one thread per request model on which your Tomcat application server, on which your Apache Tomcat web server works, all these different kind of web servers and application server works on this model, and this model basically motivates nothing but the fact that a particular thread will be in the blog state till the time it gets the response back, right? Now then comes your non-blocking IO, right? But the question is, why people and why the developers, all the team of researchers have kind of reached to a conclusion that why do we need the non-blocking IO in the first place, right? So if you can go back to the other video, then you can understand the fact that, for example, you have your application here, then you have multiple connections here, right? These are nothing but your connection. Now let's say now all these connections converts to thread here, right? So all these threads have been picked from nothing but a thread pool, right? So it's a thread pool. Now your thread pool will be of a number n, correct? Now let's say you want a bigger thread pool. Then in order to process multiple threads at the same time, you need to enhance the parallelism. How can you achieve that? By maybe increasing, vertically scaling the system. You maybe add a few more cores into your CPU, or you will enhance a main memory. All these things you will try to make that happen in order to enhance your multi-threading experience, because here you will have to have your multi-threads, right, in order to process many requests per second. Now the problem with this approach is, in order to achieve a lot of processing from this kind of system, you will have to end up a lot of computing resources in your system. And remember that vertical scaling will always have, when I say vertical scaling means there is a one machine, you keep adding over the computing resources over to that particular machine, and that's a vertically, you're scaling the system vertically, right? So you need to understand the fact that your vertical scaling always have a limitations. You cannot scale it to a larger extent. And that is why these systems are not greater systems to achieve a lot of efficiency, a processing power from in terms of handling multiple requests per second, right? So that is where people think, okay, we have to build something which is kind of a non-blocking in nature, right? Non-blocking in nature. So when I say non-blocking in nature, that means something like, let's say there is one connection comes in, and then that connection in the application, a thread is working here, right? This particular thread picked up that connection request basically, and it made a database call and it came back. So it's not waiting till the time it gets the response back from your system. Rather, it invoked that call, it executed that call, and then in there it comes back. So that's kind of a non-blocking operation, right? Now, when you are understanding the blocking operation and the non-blocking operation, also understand the fact that your blocking operation is also known as your sync operation, which is synchronous operation. And then you have your asynchronous operation, which is non-blocking operation. So you will write it as async. So it's asynchronous operation. All right. So now let's go back to our slide. So we understood what is blocking IO and then what is kind of a non-blocking IO, right? So now let's move on and understand the different components of node.js over to which the entire node.js platform has been built, right? So there is one thing is the non-blocking IO. I just explained you the concept of non-blocking, where one thread picks up your request and execute the part of request. For example, invoking a service, let's say a different microservice, you're calling an API. So you don't wait till the time the response comes back from the API. You executed the call and you move further, right? You don't wait till the time a response comes back. So that's kind of a non-blocking IO. Then you have event-driven. So event-driven system is, let's say, you are not working for anything, right? You are waiting for an event to happen. Let's say I'm sitting in my house. Now I'm not standing at my door to let somebody comes and I'll say, hi, please come in, right? So I'm sitting in my room and I will wait for an event, the bell to ring in. Now if somebody click on my bell and the bells gets ring, then at that particular moment I'll go and open the door. So that's kind of an event-driven system. Okay. Single-threaded is, you have a system and then you don't have multi threading in the system. There are no multiple threads working in order to achieve something. You already have one single thing, right? For example, a single threaded system in order to achieve something, in order to fulfill your request. So these are the important fundamentals as concepts of Node.js, right? In order to understand the Node.js implementation, the inner working of Node.js, one individual should understand all these concepts. Then we have event loop, right? So you can just hold this concept event loop for some time, maybe in the lab, because this is very interesting topic. I'll probably in the end of this lecture I'll discuss the event loop. Then you have reactor pattern, then you have the concept of callback, and then you have event demultiplexer. Now these are kind of specific technology specific terms. So let's go back and understand what is callback. All right. So now let's say this is one system. This is your, let's say, thread. Or let's not understand from the terminology of thread, otherwise you will again get confused. So what I'll say that, and even consider this as, this is service 1, right? So I'm assuming that you must be a developer, you must be QA or some kind of a software professional, right? If you are watching this video, that means that you must have an idea of services, right? Let's say this is one server and server 2. So I'm calling it service 1, service 2. Now what happens is, let's say that this server 1 wants to call this service 2 very heavily, right? So it makes a call, let's say 1000 call per minute, right? But the capacity of service 2 is to process, let's say, only 50 requests per minute. So you see the rate at which the request is being generated is very higher in comparison to the rate at which the request is being consumed and processed, right? So so these requests, all these requests that this service 1 is hitting, right? These requests must be being served by some kind of threads. Those threads will be taken from the application thread pool. Now what will happen is, if this request will take a lot of time to process and send the response back, all these threads will go on blocking state, right? Then these new threads, these new connections cannot be made to this service, and the overall system performance will go down a lot. Now the solution to this is, you have server 1 and then you have your server 2, right? Now what will happen, you will say, all right, I'm sending you a request, right? You cannot send me a response back then and there. So what you could do, I'm also sending you a callback URL. All right. So now what will happen? Now what will happen is, when you are making a request, you are sending a request, the request and a callback URL. So the way it will work is, whenever this guy is done processing this particular request, it will use this callback URL, right? And then send the response back. So this response, sending the response back, is also known as callback. Call plus back, right? So it is known as callback. So you are making a call back when you are done processing the system. So if you see, your service 1 did not wait till the time it received a response back. It invokes the request. It invokes that request, and service 1, whenever this guy is ready, it started executing that request, and whenever it's done processing the request, the service 1, it basically sends the response back, and this whole mechanism uses callback, and the URL at which it will send the callback, it will be a callback URL. So that's the address where this callback should be sent back, right? So that was the basic concept of your callback, right? So now quickly understand the event loop and the reactor pattern. Now go back again and then understand the event loop. So do you know the loop, right? You know the loop, right? And then it comes the event loop. So the loop which is taking care of the events is basically known as an event loop. So you can consider, let's say if I tell you that it's a statement, let's say while true, right? And then you waiting, let's say you are waiting from get, or let's say get event process event, right? So let's say there's a queue, and then what you're doing is you are trying to pick, it's a queue. What you're doing is, as part of this particular loop, you are trying to fetch in your one event at a time. Let's say this is nothing but your queue of, you can write it as event queue. So as part of this loop, what you're doing is you're fetching from all the event from your queue, and then you are processing one event at a time, right? Synchronously you are processing, but now you are only taking all these events from the queue itself, which is being maintained by operating system. So you see, if you see, this loop is never ending loop, right? So if I execute this kind of program in my computer, so my computer will allocate one thread to it, right? So this particular part, the part which I am highlighting it here, right? This is kind of nothing but your event loop, and this is being executed by one thread, which is again a single thread, right? So this is your event loop, and then we will understand, okay, how the analogy of node.js, how it basically fits there. And then you have the reactor, then comes back your reactor pattern, right? So you already have, by this time you already have an idea of event loop. So event loop is nothing but, for example, you have an event queue, your loop is working continuously and watching for the events from the queue. If there is one event comes in, it start executing it, and then it never ends, right? So this is your event loop, and then we will understand the reactor pattern, but not in this slide. We'll move on to next slide and we will understand the reactor pattern. And then we also understood the callback, and then you will have to understand the event demultiplexer. So event demultiplexer is something very specific to your operating system. Almost every different type of operating system had different type of event multiplexer, the implementations of event multiplexer. But the idea behind having an event demultiplexer is it's a component that basically does nothing but it's a component that is listening on many resources and many resources of the operating system, different parts of operating system. And whenever it get an idea that, okay, some activity has happened, it will take that activity and convert it to an event, right? So, and put it into an event queue, and then from that event queue, your event loop will pick that up and start executing it, and all those things will start further, right? So it basically a component that collects and queue the input output events that come from a different set of watched events, resources basically. So let's say you in your operating system you have sockets, right? So when I say socket, that means your TCP connection at your operating system level, when the TCP connection gets made, because the way HTTP works is by making a TCP connection first. TCP is the layer 4 protocol on which your HTTP, the layer 7 protocol, works on, right? So this TCP connection is being handled by operating system and under some kind of a socket. So socket under socket. So let's say your event demultiplexer is watching your resources, and your resources, let's say in this particular case, is your socket. So demultiplexer will say, okay, there is a request comes and it will automatically collect and create an event for the request and put it into your event queue. So that's the main job of an event demultiplexer. Alright, so our reactor pattern is pending. So we will be moving on our next slide, where I have, using the diagram, explained the concept of reactor pattern. That's the implementation of reactor pattern. Alright, so now let's move on. Alright guys, so if you look at this diagram, you see that's how the node.js works using the event loop. So you see, for example, you have your application here, and then you have your event demultiplexer here. Then you have your event loop here running here, right? So, and then you have event queue here. So all these brown kind of components are nothing but these are the components that is being handled by your operating system. And then the blue part is the application code that you have. So you see what happens is when somebody makes a HTTP call to your application, right? So if you see the application handling, the request first comes to your operating system, right? So, and then as part of the demultiplexer, event demultiplexer, it will see it's listening on a particular socket. So let's say it's listening on a socket which is taking care of your TCP connections. So what it does is it listens to it listens to a socket, and then for a particular HTTP request, so there will be one TCP connection will be made. It will create an event for it and then put it into an event queue here, right? Then this is our event loop. This is our single thread is keep on working, right? Restless. So it will consume that particular event, and let's say as part of that event, it sees that it has to make a disk call. Then it will submit that call to operating system. It will, let's say, invoke a operating system call, and then after some time, when the response comes back, let's say a callback has been made, then what will happen is it will execute the handler for that particular callback, right? Because this event loop needs to understand that if a callback is coming back, what will be the handler for it. So passing a handler for it will be the job of your event demultiplexer. So what it does is when the processing is done by operating system and the response comes back, so event loop, it will go back to your event loop. The response event loop will say, okay, event response has come back. It will pick up that event, the particular event, the response event, the callback event, and then it will, so there must be a handler, right? So it will execute that particular handler. So once that handler is done, so basically all your requests, the particular, and it's a basic scenario of handling the disk operation. Then you can assume that your HTTP request may have your business logic implemented in your application, may have network call, database call, all these calls as part of your logic. So what will happen is all those logic will be taken care by event loop. So event loop will not itself directly invoke all the system. It tries to take out of the most from your operating system, and it kind of passes the API network call to your operating system, and from your operating system, when it responds the response event comes back, it will execute that using its handler, it has, which is being created by demultiplexer, and then it will execute that particular handler. So if you see this event loop, it's not waiting for anything. What it does, the moment it sees that there is an event, it will execute it, right? Let's say there is a network event, so it will pick up that event, right, and execute it, and then will come back. And then whenever the response comes back, there will be an event for it, and there will be a request handler for it. There will be a handler for it. It will pick up that particular response and it will execute that particular handler. So it's a central core part, event loop, working here and there, right? Here and there. It's not waiting for any response to come back. All right. So that's your basic concept of event loop. Now we can go back and then try to understand then as part of our design part, right? So let's say here you have your app here. So this is your nothing but, let's say, your operating system, right? This is your operating system. And then let's say you have different things here, your database, your different service 1, right? So let's say this particular socket, all your connections are coming, right? Multiple connections are coming in. So now the basic part of your multiplexer is, this is your demultiplexer, sorry, and this is, it's your event queue. All right, and then here you have your, let's say, I would say you have your event loop. All right, so now your request comes in, right, and then this is nothing but your operating system, right? Now this operating system, right at the moment when the request comes in, your demultiplexer is something which is trying to collect all the events which is happening on different resources. So it's maintaining a watch list, right? So in the watch list you have multiple resources, multiple things in your operating system. So if an activity of connection made, TCP connection made, happens at a particular socket, so it's your socket, let's say for you have a port number here, and then for this port number you have a socket in your operating system, right? Then your demultiplexer is listening to that particular resource. It sees, okay, there is a connection has been made. It picks up that request and creates an event E1. Alright. Now this event will be later on picked by your event loop. Alright, so this is your event loop. Now event loop will see that as part of the request, it basically has to access your disk input output operation, right? So what it does is, let's say you have different resources of your operating system here. Now it says in order to access your disk, right, it has to access a kind of resource from your operating system. Now because you have library, because the node.js, right, comes with a library, and that library takes care of the different operating system things. So an event loop will basically do a call to your operating system saying, hey, can you try to perform this operation? So it picked up the event 1, and then your event 1, it picked up that event 1. It sees, okay, I have to make the disk operation call. It rerouted that call to operating system. Operating system tries to access disk operation. So let's say you are trying to write a file, or let's say opening a file or closing a file or altering a file, do that particular operation, and once that operation gets finished, it basically sends the event back again to, let's say, your event 2. Now what happened was, this event loop picked up that event E1, right, for accessing a file. It invoked your operating system to access the file further, and then it came back. Now what happened? It did not wait there, right, for that operating system call to finish completely. It basically executed that call and then it came back. All right. Now, and then during this movement, when it comes back, then it may have different events in this queue, because you not only have one request, you may have multiple different requests, right, coming to this particular socket. Now let's say after some time there is another E2. When I say some time, it's not minutes, it's not seconds, it's very minimal time, it's very in milliseconds, right? So there is an event again happens, let's say for your file read complete event, right? So again your event loop will read this event, and it will see, okay, this is the event I have, but how can I handle it? So if you see here, when the demultiplexer was reading the event from your resource, it basically, the responsibility is to also handling the sending the handler with the event, right? So you have a handler as well associated with the event. So it will pick up your handler, right, along with the event, and it will execute that particular handler for that particular event response. So this particular response that you see, that it's a callback response, right? It's a callback response that came back, and then same way it will work for different multiple requests. So you see, maybe during the time when it's not processing any of the event which is related to request 1, you may have your request 2, request 4, request 5 here, and then this particular your event loop may be, executing all those events that belongs to request 2, request 3, and different request n, right? So that's how, if you see in the overall processing. And then this is your callback. So what you do, the basic concept is this is your event loop, right? And then this is your queue, correct? And then it's basically, let's say, OS resource was executing a response. Now it picks up an event, right, E1, and then it basically execute it, and then it's trying to access your database, right? And then when it comes back, it will send a basic E2, and then this is for response, right? So it's basically nothing but a callback response. So it will pick up this route, right? So this is nothing but a callback response, callback response. So in order to execute this particular callback, this event loop will execute its handler, right? So and then it will keep on. It's not something that when till the time this particular database call gets completed, so it won't be waiting till the time. So it's a non-blocking operator. So this event loop is non-blocking, right? Its event loop is nothing but a non-blocking. And same thing happens right at the time that it receives the callback response. It will execute that callback response using its handler, and then it will come back, right? So whatever event that it receives is executed and come back, not execution in the terms that executing it fully and waiting till the time the execution gets completed, invoke it and then comes back. That's the main concept of your event loop. So your loop is keep on working and looking for the events in your event queue, right? So this is your event queue, or not waiting for anything. If there is an event, it will pick up and invoke it and then move further for another event. If a response callback comes back, it will pick up that response callback and invoke the handler of it, and then again move further, right? So that's the concept of your event loop. I know it's kind of a little not easy to explain. Maybe you might have not, in case you have not received an idea totally, maybe you can revisit the video and watch it again, and then you watch it in this very minimal speed. But that's the basic idea of your event loop. So there is one single thread. You see this thread is keep on working. It's not being blocked for any of the call. It's listening on. So it's an event loop. It's a loop, never-ending loop, working and looking for an event. If there is an event comes back, it picks up that, invoke that, and it moves further and looks for the another event. If the response comes back, it picks up that response and invokes that handler and then goes back. So it's keep on looking for the events and executing those, and not execution in the terms of block. It doesn't wait till the time your operation gets complete. It invokes and comes back. So that's the main concept of your the event loop, right? So even if you see here, I have created this, right? I've taken these all facts from a book, right? The implementation of Node.js, where in the book where the implementation of Node.js patterns. So I have taken all these things from a book that I explained the Node.js patterns in depth, right? So there they have explained this kind of, that in the demultiplexer you have a watch list, and then from the watch list it get an event. So demultiplexer list, you have a list which is being maintained for the different resources of operating system. So if there is an event it's not event basically directly for your Node.js event loop, but your demultiplexer in your operating system converts that request into an event. So you see it's an event driven platform, right? Even here I have written this event driven platform. So and then for this each event it's keep on processing, right? If that event is not closed, then it will consume the data and then process it further. So that's your event loop. You see it's a never ending loop for all the events, right? So if you move on, then these are the basic building blocks of your Node.js framework. So you have your core JavaScript APIs, you have your bindings, and then you have V8 engine. So you see your V8 engine is developed by Google. So it's the main engine. It's very faster, on which your Chrome browser has been developed, and then the same V8 engine is being used to power up your JavaScript. And then you have libuv. So your libuv is a library in C, if you see, right? So this is the library to make Node.js compatible with all the frameworks, right? Because in the beginning of this lecture I said that every operating system comes with its own implementation of demultiplexer. So the basic idea of Node.js is to use operating system capability as much as it can to achieve the higher efficiency, the higher processing rate, right? So if you see this library which is written in C uses the demultiplexer. So the modern operating systems has demultiplexer, which listens on the operating system resources, and then it creates an event for it, and then it pushes that event into an event queue again, which is if you see, and this event queue is maintained by your operating system. and then your event loop of your node.js. In your JavaScript, you can say, when I say node.js, that means it picks up that particular event from your queue, even operating system queue, and invokes it, executes it. Execution is not in the terms it waits till the time your execution get complete, execute it and comes back then and there. And then if the response comes back as part of your callback, this demultiplexer already created a handler for it. Event loop sees that there is another response event came into the operating system event queue. It picks up that particular response, callback response, and execute its handler, and this whole cycle goes on and goes on and goes on. So that's how your event loop works in your operating system, and that's how node.js has this capability of handling multiple requests at the same time, and that too with a single thread, right? So that was about the node.js. I hope that you may have got the maximum out of this video, right? So probably in the next video I'll cover up some other programming concept or software development concept. So till then, thank you so much, guys.